All right, next up, we're going to be doing a little bit of a recap on forces, free body diagrams, and this time specifically talk about tension. So again, force in the free body diagram is just, we represent the particle, the thing, the subject, and we draw all the forces on it, such as gravity, such as friction, such as applied force, such as normal force, such as someone pulling it, and there's many different types of forces, and one of the types of forces is tension, which is basically a string attached to something that's being either pulled down or pulled up. And just like any other force, with tensions we can separate it into the components. So just draw a simpler picture. If we have something and it's being pulled by a string at this, or a wire at a force tension T, we can split it up into the horizontal component and the vertical component. This is theta, then this becomes T cosine theta, and this becomes T sine theta. And again, tension is just a type of force that we will draw in a free body diagram and evaluate just like any other force. And that's pretty much all we'll have to need to know. And just adding forces is the same thing as adding vectors. It's pretty simple, so I think we're good for the next problem. Problem number 12. They tell you there's a sphere of mass m hanging from these two cables at a 30-degree angle each, and it asks to find the tension in one of these strings. All right, so let's draw a free body diagram for M. We know that going straight down due to gravity is mg. And in each of these directions, we have a tension pulling it in each of these directions. We could split the components up into the horizontal one and vertical, but it doesn't really matter. All we know is that these two tensions are canceling out together the mg. Okay, so for this tension at a 30-degree angle, because the sine of 30 is 1/2, we know that the vertical component of the tension is T over 2, because you're splitting it up by the sine of 30. And this one also has a vertical component of 3 over 2, so they both overlap. So basically, T over 2 is the component of this plus the vertical component of the other one, which is also T over 2, must equal mg, which is the vertical component of this. And pretty clear, we can see this just adds up to T equals mg, which is answer D.